To solve this problem, I will start again with a cartoon representation. So I'm going to represent here the ground level, okay, where the rock is going to be tossed straight up. And this here is my rock being tossed straight up with initial velocity, u, which I don't know yet exactly how much I'm going to represent. This rock is going to go up and down, and the acceleration to gravity is down, so I don't have any way to just represent everything only positive. I'm going to need to deal with positive and negative quantities. Since I want to measure the velocities and the heights above launching point, my reference frame is going to be 0 at the launching point and positive up. So this is how I'm going to measure the heights. On this reference frame, the acceleration due to gravity, which is always down, is going to be negative 10 meters per second squared. And the initial velocity is going to be plus 30 meters per second. Okay? So the general equations are going to be then, remember, equation for velocity, v equals u plus at. And on this particular situation here, v equals 30 minus 10t. And the equation for position or for displacement, s ut plus 1/2 of at squared, is going to become then 30t minus 5t squared, where I did 1/2 of negative 10 equals negative 5. Okay? So that's how I did that. And then what I need to do is just plug and chug 1 second at a time. So for t equals 1 second, v of 1 is going to be 30 minus 10 times 1. So v of 1 is 20 meters per second. And s of 1 is going to be 30 times 1 minus 5 times 1 squared. So s of 1 is going to be 25 meters. So this rock is going to be at 1, 2, 3, 4, 5, roughly here, 25 meters above ground, moving up with a velocity of 20 meters per second. At 2 seconds, I'm going to have v of 2 equals 30 minus 10 times 2. And then v of 2 is going to be v of 2 is going to be 10 meters per second. And s of 2 is going to be 30 times 2 minus 5 times 2 squared. And then s of 2 is going to be 40 meters. So 25, 30, 35, 40. My rock is going to be here, 40 meters above ground, I hope. 90 minus 4, yeah, because 30 times 2 is 60, and 4 times 5 is 20, so yes, that's right. With a velocity of 10 meters per second. I would then challenge you guys, okay, that for 3 seconds, you would just do v of 3 equals 30 minus 10 times 3, and s of 3 would just be 30 times 3 minus 5 times 3 squared, and so on. But what you're going to get is that this rock is reaching a velocity of 0 with a height of 45 meters. And then it's coming down, and as it's coming down, in 4 seconds, it's going to be passing by the same position, but now the velocity of negative 10 meters per second. At 5 seconds, it's going to be coming down here with a velocity of negative 20 meters per second. And finally, it's going to take 6 seconds. It's going to come back to the ground with a velocity of 30 meters per second. Please notice this here, okay? The velocity at the top is going to be 0, always. But acceleration at the top is still the same g as before, okay? Another thing is, the time going up is going to be the same as the time coming down. Time up equals time down. And finally, for every point at m, the speed going up is the same as the speed coming down. So, speed up equals speed down. These properties here are extremely useful in solving free fall problems. So I would say memorize them if you have a good memory.